Okay, welcome to I Square Maths Academy, where numbers actually meet mastery. In our last section, we actually looked at the integral of the square root of a squared minus x squared dx. Now today, I want us to look at 1 all over the square root of a squared minus x squared dx. Now, we said when you're integrating a function like this, you substitute x is equal to a sine theta. Yes. Now, if x is equal to a sine theta, it means a square minus x square will be equal to a square minus a sine theta all squared. Yes, because x now is actually a sine theta. So here, a square minus x square will be equal to a square minus, now this a square sine theta means a square a sine theta times another a sine theta, and that will give us a square sine square theta. It therefore means that here we have minus a square sine squared theta. So a square minus x square will be equal to, now a is common, a square is common rather. So here we have a square in brackets 1 minus sine squared theta. Yes. So recall from trigonometric identity. Yes, from trigonometric identity. Yes, sine square theta plus cos square theta is equal to 1. And of course, we know that cos square theta is equal to 1 minus sine square theta. Yes. Yes. Sine square theta plus cos square theta is equal to 1, irrespective of the magnitude of theta. Sine square 5 billion plus cos square 5 billion is equal to 1. Now, it means here that if sine square theta plus cos square theta is equal to 1, it therefore means that cos square theta is equal to 1 minus sine squared theta. Now, coming back to this, now a square minus x square will be equal to h square in brackets. Now, this 1 minus sine square theta is cos square theta. So here we have it as cos square theta. So now the square root of a square minus x square will be equal to the square root of a square cos square theta. And of course, we all know that the square root of a number is the number that will multiply itself to give you the number inside the radical. So it therefore means that our square root of a square minus x square will be equal to, when you look for the square root of a, is a. The square root of a square rather is a. The square root of cos square theta is cos theta. So it means the whole of this value is equal to this, and is equal to a cos theta. Now coming back to the integral, we have integral 1 all over the square root of a square minus x square. Here we have the x. Now this will be integral 1 all over. Now the square root of this, which is square root of a square minus x square, we said is a cos theta. So here we have a cos theta. Then here we have the x. Yes, the x. Now let's look at this now. Let's look at this equation here. We said x is equal to a sine theta. Now let's look at the x all over the theta. If you differentiate a sine theta, it gives a cos theta. Yes, because the derivative of sine theta is actually cos theta. So now our dx, when you multiply, when you cross multiply, the x will give us a cos theta d theta. Now it therefore means that integral 1 all over the square root of a square minus x square dx will be equal to integral 1 all over, here we have a cos theta. Now, the value of those dx now, look at the value of the x. Yes, the x is a cos theta the theta. So we have a cos theta the theta. So now in this case, this a will go with this a. Cos theta will go with this cos theta. So it means integral 1 all over the square root of a square minus x square. The x will be equal to integral. Here we have 1 d theta. Yes, 1 d theta. So it therefore implies that integral 1 all over the square root of a square minus x square dx, which is integral 1 d theta. When you integrate 1, it gives theta plus c. Yes, when you integrate 1, it gives theta plus c. But remember, from this equation here, we said x is equal to a sine theta. So it means sine theta is x all over a. So to get the value of theta, theta will be equal to the sine inverse of x all over a. So it therefore means that the integral of 1 all over the square root of a square minus x square, the x will be equal to theta. And the value of theta is this now. So we have sine inverse of x all over a plus constant. So that is for the B. Yes, that's the B under trigonometry substitution. Okay, so in our next class, we are going to be looking at that of C. Okay, that is C, where we have to substitute tan theta. Thank you for listening.